A Tier 2 U.S. bank shipped an AI-generated change to its core last quarter. It moved money. Nobody can prove who authorized it. The exam is in 90 days. This report is what our audit team found across more than 100 engagements in banking and fintech in the first half of 2026. 4 failures, every one of them examinable. Most banks cannot answer them today. 2 things before we start. First, everything in this report is anonymized. Our clients are serious institutions, national banks, regional banks, payment processors, chartered fintechs. They do not need our marketing to survive, so no logos, no code fragments that could identify a system, no timelines that map to any known event. Second, we are not naming AI vendors. The failure patterns we are about to walk through appeared across every leading AI coding assistant we tested. This is not a vendor problem, it is a systems integration problem. Naming vendors would let leaders in this audience assume the fix is switching tools. It is not. Every finding in this video maps to at least one of these published frameworks. If your risk committee, your internal audit function, or your MRM team wants to challenge anything you see here, the citations are on screen and in the description. The first pattern. In 87% of the banking systems we reviewed, AI-generated changes had cleared human code review, passed the entire test suite, and made it to production, then failed under adversarial load in ways the review process was structurally unable to detect. The pattern is consistent. AI-assisted code passes what it is measured against. Reviewers evaluate correctness of intent. Test suites evaluate expected behavior. Neither evaluates behavior under coordinated adversarial input against transfer, settlement, or ledger operations. So the code ships. What we see in our load studies against banking systems is a cliff. Under normal conditions, the transfer service looks correct. As concurrency and adversarial input rise, 3 governance properties collapse together: transaction isolation, item potency, authentication binding. All 3 degrade non-linearly. All 3 are named directly in the FFIEC Information Security Booklet. Our published research on this pattern shows that governance properties measured at 95% under normal conditions collapse to 0 under production pressure. What we find in field audits of banking systems matches what we measured in the lab. This is the finding your load testing will not surface because your load tests are not adversarial. They are volume tests. The second pattern, and this one is what senior CISOs at banks are least prepared for. Banks increasingly use AI to assist in code review, pull request summarization, change approval, and even change advisory board documentation. In 63% of the environments we audited, we demonstrated instruction leakage from non-code channels into the AI-assisted review path. 3 vectors we tested: instructions inside pull request descriptions, instructions inside code comments, instructions inside linked design documents that the AI is asked to summarize for a change board or an internal audit reviewer. In every environment where we found this exposure, an attacker with commit access to any dependency, any documentation repository, or any linked artifact could steer the AI's summary of a change in a direction that misleads the human reviewer. In a bank, that reviewer is often the person signing the change advisory board approval that satisfies SR 11-7. This is not a hypothetical. It is a specific class of supply chain attack that banks do not currently model in their threat inventory. If your organization has adopted AI-assisted review anywhere in the SDLC, and you have not run a red team exercise specifically against the review path, you have this exposure. Your model risk management framework does not cover it because the model in question is not deployed to customers. It is deployed to your engineers. The third pattern, infrastructure and configuration, written by AI is dangerous, not because of what it includes, It is dangerous because of what it omits. Across the banking systems we reviewed, 71% of AI-generated infrastructure changes omitted at least one governance-critical directive that had been present in the same team's handwritten baseline from the year prior. 4 representative cases from the banking audit population. Audit log storage without retention lock. Payment service roles without conditional constraints. Core network zones without egress rules. Encryption defaulting to provider-managed keys instead of the bank's own. In every case, the AI-generated version deployed, passed the pipeline, reviewed clean, and silently removed a control the bank already had. This is the finding regulators are least prepared to examine and most likely to catch by accident. There is no anomalous artifact in the change. The AI did not add anything harmful. It removed something protective. Static analysis will not flag it. Traditional review will not catch it because reviewers evaluate what is on the page, not what used to be. The 4th pattern, and this is the one that has already appeared in supervisory examinations we have supported. When a regulator asks how a specific change was authorized, produced, tested, and approved, banks using AI-assisted development are increasingly unable to answer. 6 questions a competent supervisory examiner will ask about any AI-assisted change to a system that touches money, customer data, or reporting. In the banking audits we conducted, the median institution could answer 1.5 of these with a verifiable record. The rest were reconstructed from memory during the examination itself. This is the finding that changes how regulators write their next set of guidance. It is already happening. FFIEC updated its handbook this year. The OCC is running horizontal reviews on AI use in the SDLC. The PRA has published its position. The EU AI Act, Article 12, is explicit about this record. The remediation is not more documentation. Documentation degrades over time and lies under pressure. The remediation is cryptographic provenance. Every AI-assisted change bound to a verifiable record of the model, the prompt, the context, and the human authorization. The auditor verifies the record, not the institution's memory. One matrix explains all 4 findings. Traditional code review at a bank is designed to evaluate the intent of code. That is 1 cell of an 8-cell grid. The AI now produces code, configuration, review artifacts, and provenance. Each of those needs to be evaluated for both intent and behavior. Traditional review covers 1 of 8 cells. This is not a critique of your engineers or your reviewers or your change advisory board. It is a structural gap between how code is produced now and how it is inspected inside a supervised institution. The gap widens every quarter that AI assistance grows and inspection does not. Your examiner will close it for you if you do not close it first. The architecture that closes all 4 findings has 4 layers. None of them live inside the AI. All of them live around it. The second layer, the policy enforcement gateway, is what closes findings 1 and 3. Governance properties become preconditions of deployment. They are not assumptions inside the AI's output. They are contracts the platform enforces, regardless of what the AI wrote. This is the pattern the FFIEC handbook update points toward without naming. The third layer, cryptographic provenance, is what closes finding 4. Every AI-assisted change is bound to a verifiable record that the examiner can check without trusting the bank's own systems. This is the pattern our RIA framework implements for regulated institutions. It is also the pattern the next generation of supervisory guidance is going to require. Not next decade, next examination cycle. The fourth layer, continuous adversarial evaluation, is what closes finding 2 and detects finding 1 before it reaches the examiner. Systems are tested against the way they will actually be attacked, not the way they are expected to behave. 3 concrete steps for the leaders watching this. Chief Risk Officer, Chief Information Security Officer, Head of Internal Audit, Head of Model Risk Management, Chief Technology Officer. 1. Commission a review path audit, not a code audit. An audit of the review process itself, treated as the attack surface. If your bank uses AI-assisted review anywhere in the SDLC, this is the fastest way to surface findings, too, before an examiner does. It is a 2-week engagement. 2. Have your infrastructure team compare the last 12 months of AI-generated infrastructure changes against your handwritten baseline from the year prior. Look for silent regressions in the 4 categories on screen earlier. This is a 5-day exercise for a competent platform team. Every bank we have run it against has found at least one. 3. Ask your development platform owner exactly this question. Show me the cryptographic record of the last AI-assisted change that went to a production system that touches money or customer data. Bind it to the model version, the prompt, the context, and the human authorization. If the answer is a link to a ticket or a Git commit, you have finding 4. That answer will not survive the next examination. 3 resources. Our published audit checklist is available at the link on screen and in the description. The full reference architecture white paper covers each of the 4 layers in production detail. Banks and fintechs who want to run this against their own environment can request a technical briefing with our audit and engineering team through the 3rd link. We do not run outbound sales. Institutions who work with us come through referrals, published research, or a briefing request. If this report reflects a pattern you recognize in your own systems, one of those 3 doors is open. This is the algorithm.